What if I told you that one tiny piece of text completely changed the way websites are built? A payload so simple, so short that for years it exposed vulnerable web applications around the world. No malware, no hacking movie magic, no supercomputer, just a few characters typed into a login box. And today we are going to see exactly why it became one of the most famous vulnerabilities in cybersecurity. This is SQL injection. But here's the crazy part. The vulnerability wasn't hiding in the database. It wasn't hiding in the server. It was hiding somewhere. It was hiding in something developers trusted every single day: user input. Before we begin, this video is strictly for educational and security awareness purposes. Everything demonstrated here is performed in a controlled lab environment on intentionally vulnerable applications. Never attempt to access systems, websites, or accounts without explicit authorization. The goal is to understand vulnerabilities so we can build more secure applications and become better defenders. Now, let's break the internet's most famous SQL injection. First, let's see how login systems are supposed to work. When you enter a username and password, the website sends those values to the backend. The backend then creates a database query that looks something like this. Select from users where username equals your username and password equals your password. Simple. The database checks every record. If it finds a matching username and password, access granted. If it doesn't, access denied. Pretty straightforward, right? Well, only if the developer builds it correctly. Here's where things start getting dangerous. Databases don't understand intentions, they only understand instructions. And if user input gets mixed directly into SQL commands, the database can't always tell the difference between data and code. That single mistake created one of the most dangerous vulnerabilities in the web security history. Meet the payload that every cybersecurity student learns about, the legendary payload, or 1 equals 1. Looks harmless, looks ridiculous, but let's break it apart. The first code closes the original string or introduces a new condition, and 1 equals 1 creates a statement that is always true. 1 equals 1 every time, no exception, and that's where the magic happens. Let's test our vulnerable demo application. I will enter a username, let's say Benjamin1234. Then normal password, I will enter, let's say bench1234, and then I will click login. You can see that access is denied. Exactly what we had expected. The credentials don't match anything in the database. Now let's try something different. Instead of legitimate username, we'll enter our SQL injection payload, or 1 equals 1. And for the password, literally anything. It doesn't matter. Ready? 3, 2, 1, login. Then boom, we are in. No valid credentials entered. No correct password provided. The application accepted the request because the vulnerable query logic was manipulated into evaluating as true. So, why did this shock developers? Why did this actually shock developers? For years, developers trusted user input. They assumed users would only enter usernames and passwords. Attackers thought differently. Instead of entering data, they entered SQL logic, and vulnerable applications executed it. That realization completely changed how security applications are built today. Now, let's take a look at how developers can stop this. The good news: modern defenses are extremely effective when implemented correctly. Number one defense method is prepared statement and parameterized queries. This separates user inputs from SQL commands and prevents data from becoming executable SQL. Then number 2, input validation. Only accept the types of data you actually expect. Then number 3, we have least privileges. Even if an application is compromised, the database account should have minimal permissions. Then number 4, web application firewalls. They can detect and block many common attack patterns. And finally, regular security auditing. Find vulnerabilities before attackers do. SQL injection may be old. Yes, I repeat, SQL injection may be old, but it remains one of the most important lessons in cybersecurity because it teaches a principle every developer should remember. Never trust user input. Not today, not tomorrow, not ever. If you enjoyed this breakdown, hit that like button, subscribe for more cybersecurity content, and comment below which vulnerability should we explore next. Which vulnerability should we explore next? XSS, CSRF, command injection, or something even crazier? Until next time, stay curious, stay ethical, and stay secure.